scaled up to fly a human, or would there be problems making it 20 times as big?
I think it could be scaled up, but the problem is this. Each time, okay, if you want to keep the weight of the subsystems down, such as the power and pump subsystem, the way you do that is by limiting the amount of power you have and therefore the size of the pump, okay? So, for instance, on this scale that you see here, it would take around 30 days pumping, just acquiring about 1 kilogram of propellant a day, for this to acquire its CO2. In other words, you land and it will take you 30 days to fuel it up, so to speak. Well, if we're just doing little robots, no problem. It takes 60 days. Who cares? I mean, scientists will want at least that much time at a new site just to do the exploration. But here, when you're talking about if you're talking humans, you're taking off, you're landing, and now they're committed to that new place for a month or two before they could possibly leave. Maybe that's acceptable. But it seems to me to be not the optimal technology for human transportation, although, I mean, you can make a case for it, it's just not how I see it. But for robotic exploration, it's perfect.
Did you look at anything more complicated, like eliminating the pressurization by putting a turbocharger in and driven off of the heat?
Well, the CO2 is self-pressurized. There's no complication there at all. So there was no need for such a system.
It must be pumped up to there's a pump, the solar energy is pumping up the CO2 into the tank. Right?
That's how you store the CO2, yes.
What's the minimum pressure that you can get?
Oh, you're talking about using the CO2 in real time.
Yeah.
That'd be hard to do because the Mars, I mean, it might be possible, but it'd be hard. The Mars atmospheric pressure is about 1% that of the Earth. So to try to acquire the CO2 in real time and then heat it, it was basically running a jet engine, essentially, as opposed to a rocket plane. Some advantages to that, that's for sure. But it's kind of like flying at 100,000 feet on Earth. Now, it's true there's an airplane that can fly at 100,000 feet on Earth. But it heats the air by combustion with a fuel that's sprayed into the air. And that can happen very fast. Whereas we would be heating the air with conduction from preheated elements. And to try to do that at those kinds of speeds, it'd be very challenging. I'm not saying it's physically impossible. It might be possible. But this is a much simpler kind of thing. So,
I came in late, you might have covered this, but what do you think about putting this engine on a blimp type of aircraft?
For blimps, I don't know. The blimps, there's a lot of weight here, and you can certainly fly balloons and dirigibles on Mars, but payload is limited due to the thickness of the air. So it seems more advantageous to me to fly it on an aircraft. Other questions?
What kind of a guidance system would you have in mind if the range is, say, 150 or 200 miles, which I guess would be over the horizon from the remote pilot?
Oh, well, in this instance, we would be flying it from Earth, and what you would do is you would upload it to its computer in advance, the full sequence of commands for navigation. For terminal descent and landing, once it had reached appropriate coordinates, it would then use radars and so forth so that it could see terrain hazards of this sort. In other words, you don't want to completely program the flight, just say, X, Y, Z, and good luck. So it would have some built-in hazard avoidance and so forth, but the navigation program would be built into it. In other words, you'd say, turn to course, 37 degrees true, and proceed at this speed for this amount of time, and then decelerate and land, and then you have a landing sequence that has terrain hazard avoidance built into it. So no, you wouldn't be piloting like we would pilot it, like we piloted that plane with an RC guy driving the plane. Other questions? Yes.
Having not been awarded the Base 2 study, what's the next practical step for the Gashopper? Is this technology still being developed by Pioneer Astronautics, or is it kind of in a holding pattern right now?
Well, at our company, it's currently in a holding pattern, although we still have the Gashoper airplanes. We would hope to bid this on future opportunities for Mars exploration missions. We actually, Mars Society conceived of the idea of having a small Gashoper airplane contest for universities, based student groups to build Gashoper airplanes comparable to the RC one that you saw before here. And we'd have a fly-off contest of some kind. It'd be a great engineering challenge to aerospace students in particular. But I was supposed to make that happen, and I got diverted and did not make it happen. But perhaps next year we will, and be a great thing.
If anybody wants to help on organizing that, we'd certainly like to hear from you as well.
Yes.
Concerning hazard avoidance, what about like dust storms or some way of keeping the thing on the ground if the wind speed picks up and wants to flip it?
Well, okay. Now, I would not want to fly it during a dust storm, but that's easily managed. You just don't fly during dust storms. I do not really think that dust storms would create a hazard to just routes on the ground. The dust storm high-speed winds are winds aloft. They're not surface winds. I mean, in 4 years on the surface of Mars, the Viking landers never encountered wind speeds above 40 miles an hour, and typically less than 1/10 of that. But the maximum dust storm kind of speeds, in other words, the 100-mile-an-hour winds are not active on the deck. Any other questions? Well, in that case, thank you very much.